Namaste to all of you. This is the next class, Permutations Combinations, class 11B. Today also a few bits and a concept I will explain. Okay, one example today I will explain. Here it is the example is, okay, listen all of you. Here the example is, in a chess tournament, in a chess tournament where the participants were to play one game with another. Okay, every participant play one game with another. Two chess players fell ill. Here the bit is like this: two players fell ill, having played three games each. If the total number of games played is 84, then number of participants in beginning is dash. This is the bit. Once again, in a chess tournament where the participants were to play one game with another. Okay, two players fell ill, having played three games each. Okay, if the total number of games played in the tournament is 84, then number of how many participants are there in the beginning. Okay, listen all of you here for this one. For example, if you observe, let in the beginning n players are there. N players will be there. So total number of games in general NC to you will get it. But by the data, here from the data, two players fell ill, having played three games each. Means those two players, each player play three games. So total they played 6 games plus. After that they removed from the tournament. So remaining how many players are there? n-2. So remaining n-2, how many games they will play? n-2 c2. Since here, if you observe, for playing of a chess game, we have to select 2 members. How many members play chess game? 2 members only. So out of n-2, every selection of 2 members, you will get 1 game. So remaining n-2 members, they can play n-2 c2 is equals to how many games they given here? 84 is the value. Now we have to find the n value. Once again, in a chess tournament, okay, each participant have to play one game with another. Two players fell ill, having played 3 games each. So 2 players means one player 3 games means second player also 3 games, total 6 games. Then among n-2, remaining n-2 members will be there. n-2, how many games they can play? In order to play a chess game, there are 2 participants will be there. So n-2 c2 is equals to 84. Then simplify this value. 6 plus n-2 c2 means n-2 into n-3 by 2 is equals to 84 is the value. With this one, n-2 into n-3 by 2 is equals to, if you bring this value this side, 78. Then after this, n-2 into n-3 is equals to 156 I can get. Then this value I can write 12 into 13. That is, here it is the value, n-2 is equals to 13. That implies n is equals to 15. So in the beginning of the tournament, there are 15 players are there. Okay, so here in this bit, formation of this equation is important. After forming this equation, then you can get easily. So each player, 2 players fell ill. They played 3 games each. So 6 games plus remaining n minus 2 persons will be there. In order to play a chess game, there are 2 members we have to select. So how many selections will be there? Out of n minus 2, we have to select to n minus 2 c2. Therefore 6 plus n minus 2 c2 equals 84. Then simplify the whole equation. Automatically you will get the value as n is equals to 15. Okay. Next, one more example I will explain here. Next example. For example, here it is a bit. 10 persons are seated around a circle. 10 persons are there. 10 persons. They are seated around a circle. They are sitting around a circle. Then here it is a bit. The number of ways of selecting 3 persons out of them, okay, if no two persons are adjacent to each other. No two persons are adjacent to each other. This is the bit. Okay. For example, 10 persons are there. Those 10 persons are seated around a circle. The number of ways of selecting 10 persons out of them if no two persons are adjacent to each other. So 10 persons are there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Like this. 10 persons are there. They are sitting around a table like this. So out of these 10, how many I have to select? 3 persons. So 10c 3 ways I can select. So 10c3 means 10 into 9 into 8 by 3 factorial means 6. So 3 2 times 3 3 times which is equals to 120 I can get. 120 ways. But among these selections I have to subtract the 2 consecutive selections and 3 consecutive selections. So how many 3 consecutives will be there? 1 2 3, 2 3 4, 3 4 5, 4 5 6, 5 6 7, like that. 10 1 2 means out of these 120, 3 consecutive selections plus 2 consecutive selections I have to subtract. So which is equals to 120 minus 3 consecutive selections. How many 3 consecutives will be there? Already we get 10 we got, minus 2 consecutive. 2 consecutive, 1 is different. For example, if I select 1 2, I can't take these 2. Why? Because 1 2 3 already I subtract here. 10 1 2 I subtract here 3 consecutive. So 1 2 4, 1 2 5, 1 2 6, 1 2 7, 1 2 8, 1 2 9. These also selection nothing but 2 consecutive, 2 adjacent members are there. Even this selection also I don't want. I have to subtract this one. Like railway stations bit like that. So how many chances are there? 1 2 4 like that if you count. 1 2 3 4 5 6. So for 2 3 also 6. For 3 4 also 6. Like that how many will come? Okay, for 10 1 also again 6 will come. So these are also 60 ways I can get. So 120 minus 70 which is equals to 50. So the number of ways of selecting 3 persons out of 10 those who are sitting around a circular table, the number of ways of selecting 3 such that no 2 persons are adjacent is nothing but 50 number of ways. Okay. Next, one more bit. Few students they asked me. For example, they have 7 colors are there. 7 colors are there. How many number of flags I can make? How many different colored flags I can made with the help of these 7 colors by using any number of colors? That is the bit. So here how many different colored flags I can made with the help of these 7 different colors are there. Okay, I can use any number of colors. So maybe I can use for flag 1 color, that is 7 ways are there. Maybe I can use 2 colors, 7p2. Maybe I can use 3 colors, 7p3. maybe I can use 7 colors also. So 7p7, this is the answer. Once again, here it is a bit, there are 7 colors are there. Out of these 7 colors, how many different colored flags I can make with the help of these 7 colors? Either I am using any number of colors, so like that they given. Up to 7 possibilities there. So how I can make? But one time only we have to use it without repetition, like that they given. So here maybe with 1 colored flag I can make now. With 2 colored flags I can make. 3 colors I can make. Up to 7 colors also I can make flags. So 1 color means out of 7 colors I have to choose 1. So 7. Out of 7 I have to select 2 and arranging them. So flag means here the for arrangement of the color is also important. Maybe for example green, white. This is one flag. Otherwise white, green. This is also one more flag. So here the arrangement is also important. Na? So 7 plus 7p2 plus 7p3 plus up to so on 7p7. These are the number of different colored flags by using 7 colors at a time. 7 colors not at a time, 1 or more. This is the possible case. Next, before this, one concept already I given. What is the concept here? All of you listen carefully. The concept is, for example, this is the total number of combinations. Total number of combinations. Total number of combinations. This is the concept, total number of combinations. What is this concept? Listen. For example, if I have p similar things, if I have p similar things, out of these p similar things, in how many ways I can select one or more things? In how many ways I can select one or more things? How many ways I can select? P ways. Already this concept I given. For example, if I have 5 1 rupee coins, I have 5 1 rupee coins I have. Out of these 5 1 rupee coins, I have to select 4 coins. How many ways I can select 4 1 rupee coins out of 5 1 rupee coins? Can I use 5c4? No, this is wrong. Why? Because all these are similar only. There is no 5c4. 5c4 means 5. Out of 5 1 rupee coins, I can select 4 1 rupee coins in 5 ways. No, that is one way only. Since they are similar, whenever the similarity is there, if you pick 4 coins, automatically you will get 4 1 rupee coins only. There is no difference. So here the thing is, out of p similar things, p similar things are there. Out of these p similar things, I can select r things in how many ways? That is one way only. Already this point I given. If I have p similar things, out of p similar things, I have to select r things. In how many ways I can select r things? Nothing but one way only. Otherwise, for example, n things are there. Here also you may take n things, no problem. Out of n similar things, you have to select r things, but here similar things are there. We have to select r things in one way only. Best example, this one only. 5 1 rupee coins, my aim is to select 4 coins. In how many ways I can select? One way only, not 5 way. That is one way only. Since every selection, automatically if you pick 4 coins, automatically what about the 4 coins will be 4 1 rupee coins only, since they are similar. Same here also, n similar things are there. Out of these n similar things, I have to select r things. In how many ways I can select r things out of n similar things? That is one way only. For example, simply if they given n different things are given, I have to select r things. Then how many ways I can select? Then you can go with NCR. When if the things are different, then NCR you will get it. If the things are similar things, you can select r things out of these n similar things in one way only. Now with the help of this one, if the p similar things are there, out of these p similar things, I have to select one or more. How many ways I can select? So one or more means maybe I can select one thing, that is one way only. I can select 2 things, that is also one way only. I can select 3 things, that is also one way only. Up to so on p things also I can select, that is also one way only. So 1 plus 1 plus 1 plus how many times I got 1? P times. So out of p similar things I can select one or more things in p ways only. Next point, for example, p similar things are there. P similar things are there. Out of these p similar things, how many ways I can select? 0 or more things. 0 or more things. 0 or more things means I can select maybe 0 things, that is also one way. I can select one thing, that is also one way. Like that I can select p things, that is also one way. So 1 plus 1 plus 1 plus how many times I got? P plus 1 times. So this is nothing but p plus 1 times. So here it is the one important point. If p similar things are there, out of these p similar things, 0 or more things I can select p plus 1 ways I can select. Now in this total number of combinations, here it is the point is the total number of combinations, the total number of combinations of p plus q things, p plus q things taken any number at a time, when out of these p plus q, p things are alike one kind, p things are similar, alike means of one kind, and q things are alike of second kind, alike of the second kind, is formula p plus 1 into q plus 1 is the value. Once again, here it is the one important point. The total number of combinations of p plus q things taken any number at a time, when p things are alike, that means p things are similar things, and q things also similar things of the second kind, is p plus 1 into q plus 1. Okay, since out of here p things, p similar things are there now, out of p things, how many ways I can select 0 or more? P plus 1 into here q things also there. Even similarly, out of q similar things also, how many ways I can select 0 or more things? Q plus 1. Therefore, the number of ways is equal to p plus 1 into q plus 1 is the value. Okay, means here for your explanation, p things, q things, I can select 0 0 things like this. This is 1. Maybe I can select 0 1, 0 2, up to so on 0 q things. Till here how many I got? Tell me. Till here how many I got? 0 1 2 up to so on q, means till here q plus 1. Next again here combination. Out of p, maybe I select 1. With this combination 0 I can select, 1 1 I can select, 1 2 I can select. Here how many you will get like this also again? Q plus 1. Like that if you proceed, how many ways you will get? Like this, p plus 1 into q plus 1. This is also one more important point. The total number of combinations of p plus q things taken any number at a time. Any number means either 0 or more at a time. When p things are alike of one kind, q things are alike of second kind, is nothing but p plus 1 into q plus 1. Similarly, not only p plus q, we can generalize this point as p plus q plus r things are there. You can take like this, p plus q plus r things taken any number at a time, when p things are alike of one kind, q things are alike of second kind, r things are alike of the third kind. Then what is the value will be? P plus 1 into q plus 1 into r plus 1 is the value. Once again, one more point, give me answer. The total number of combinations, listen the word carefully. The total number of combinations of p plus q things taken at least one or more at a time, when p things are alike and q things are alike things of the second kind, is what will be the answer? Once again listen, the total number of combinations of p plus q things taken one or more at a time when p things are alike of the one kind, q things are alike of the second kind is, what is the value will be here? It is here the answer will be p plus 1 into q plus 1 minus 1 is the answer. One or more given, so one or more means this particular selection. Out of p I can select 0 things, out of q I can select 0 things. This one selection is there na, this one selection I have to subtract. If I subtract this one, I can get the total number of combinations of p plus q things, taken one or more at a time. This is the case, nothing but one or more at a time. This is nothing but this one or more at a time out of p plus q things. Out of this, p things are similar of one kind, q things are similar of the next kind, like this. Remember this one also. Now how they will frame the bits basing on this? Here the bit is one example I will explain. Listen the example. Find the total number of combinations of 10 things. Find the total number of combinations of 10 things when 6 things are alike of one kind, and 4 things are alike of second kind. What will be the answer? Will be here it is 6 plus 1 into 4 plus 1, which is equals to 35 is the value, like this. Find the total number of combinations of 10 things when 6 things are alike of one kind and 4 things are alike of the second kind. What will be the answer? Will be 6 plus 1 into 4 plus 1, which is equals to 35 is the value. Like this we can proceed. For example, one more example here. Listen and tell me. The total number of combinations. Find the total number of combinations of 8 different things. 8 different things. What will be the answer? 8 different things they given. Immediately if they given 8 different things, what is the value will be? 8c0 plus 8c1 plus 8c2 plus, means out of 8 I can't select anything. Out of 8 I can select one thing. Out of 8 I can select 2 things. Like that, what is the possibility? 8c8, which is equals to 2 power 8, which is equals to 256 is the answer. So whenever the different things are given, this is the concept, and similar things are given, this is the concept, and this is nothing but total number of combinations. So this is the concept, total number of the combinations. Okay, listen this video properly and prepare yourself classroom notebook and try to solve the assignment. Okay, and next class I will explain new concepts which are geometrically related concepts few, and number of devices, even the number of devices also, even divisions, odd divisions, everything I will explain. And one more thing, for the next class it is our responsibility to take a look one time binomial theorem. Binomial theorem for rational index already we given in our classroom notebook. One time revise the entire that particular concept. Okay.